Thank you. All right, so I'm Christopher Neugebauer. I am a senior engineer currently working as a technical lead on communications engineering here at AlphaSites. I'm based in California, work for our New York office, and I'm talking to you all from London, which is very exciting. So our team, our communications engineering team, has been working on a Greenfields backend service written entirely in Kotlin, and we've been solving a whole pile of interesting problems along the way as we've discovered how to use Kotlin as an alternative implementation language to Java. So today I'm going to talk a bit about the work that we did to rethink how a Kotlin service we've been working on interacts with its database. If you have questions, you can save them to the end. If I haven't answered them by the end of the talk, you can ask in Q&A, or you can ask me when I'm not talking, I guess. So my background, however, it doesn't come from Kotlin or Java. I've been working with Python for most of my life. I'm on the board of directors of the Python Software Foundation. I run a community-based Python conference. So while I'm not going to be talking about Python today, my background in Python informs a lot about this talk. So while Kotlin does a great job of replacing the Java language in backend services, it's still very easy to write Kotlin that looks a lot like enterprise Java. I don't have a background in enterprise Java, so my idea of what a good application looks like doesn't necessarily agree with what enterprise Java developers think a good application looks like. Most of my backend engineering experience before I started working in Kotlin comes from a Python framework called Django. It has a magical pony for a logo. I'm not going to dwell on the logo too much, but I think it's worth bringing you up to speed with why I think the way that I do before I dive into the rest of the talk. So Django provides you with tools for making web applications out of the box. It has a library for defining and processing input forms, has a library for rendering templates, it has a URL routing framework. But most importantly, it has a data management layer, the Django Object Relational Mapper, the Django ORM. The idea behind Django's ORM is that you define yourself a plain old Python class, and every field in that class represents a typed database column. You type some incantations at the command line to make the database happen, and then suddenly you can create instances of your model, and you can save them to the database. Importantly, the ORM makes sure that it's always in a position to persist objects. So if you're not building an application that's going to be highly concurrent, you only have a small number of users, it will manage transactions for you if your database is a database that requires transactions, such as Postgres. It's very easy to interact with a database out of the box in Django, and then you can incrementally learn more features of your ORM as you need to use them. You can also query the database using plain old Python in most cases. You can either get a single object using this get thing, or you can ask for query sets, which represent like full sets of results. So in Django, for better or worse, writing SQL is strongly discouraged. The idea is that you write your queries using objects where you can. If the ORM doesn't support your query, that's when you start writing SQL. Django has support for that, but it's not usually your primary use case. So that ends my quick primer in Django. Now we can talk about Kotlin, which I think is why you're all here. Kotlin's a really interesting language for backend service development because the designers of Kotlin decided that interoperating with legacy Java features should be at the core of the language. And this means that Kotlin already has quite a vibrant ecosystem for backend development. And that's entirely because Java has a quite vibrant ecosystem for backend development. If things work in Java, they tend to work in Kotlin as well. But this can be a double-edged sword because despite being interoperable with Java, Kotlin is a really opinionated language. Kotlin first libraries have an expressiveness that usually isn't matched by Java-focused counterparts. And Java is also quite old. It's been popular for development work for almost 30 years now. And a lot of libraries that people use all the time in Java have a history going back as far as the first releases of Java. And those libraries made design decisions that might have been good back then, but they're not design decisions that we might make now. So Hibernate, in particular, predates Django by 5 years. It made some decisions that reflected how people thought about ORMs 5 years before Rails or Django came around. It doesn't reflect design decisions that have been learnt about ORM design since then. But Hibernate is also really heavily used. It's very stable, it's very reliable, and a lot of software relies on it. If you want a Java-focused ORM, you won't get fired for selecting Hibernate. And if you want an ORM that's a joy to use in Kotlin, you're out of luck. There are a couple of viable ORMs that are out there that are designed to be really nice to use in Kotlin, but they're not yet stable. JetBrains is working on something called Exposed. It looks like it might be a good option in a few years' time, but it's still in an early beta. So let's go back to Hibernate. Hibernate these days is access to a thing called the Java Persistence API. The Java Persistence API is an attempt to abstract away the details of working with specific databases so that you can work with a generic API instead. It's very stable. It hasn't been changed in more than 10 years. So at the core of the JPA is the EntityManager class. The EntityManager is what represents your connection to a database. If you wanted to get yourself an entity manager, you might manually write some connection code and get an entity manager once you've configured everything. Most of the time you don't do that. You'll use a configuration framework to magic an entity manager into being. In my case, I use Spring and Spring Boot. You provide some configuration instructions to Spring Boot, and then you get an entity manager that can be injected in all manner of places. That's the perspective I'm going to be talking about from here on in. So once you have an entity manager, there's two ways out of the box for dealing with simple storage operations. You get find. Find is pretty simple. It helps you look up database entities by a primary key. You also get persist, which lets you persist an entity to the database. Using the entity manager to get a thing out of the database is very, very easy. You just say, hey, database, find me that thing. You have to ask the entity manager to find you an object, which is sort of the opposite way of thinking if you're a Django or a Rails person, where you ask the class for an instance of the object. But it's not a huge step to take to think about it the other way around. On the other hand, persist does not work the way that you would expect. If you get given an entity manager, you can't immediately persist an entity to the database. Because if you have a database that requires transactions, persist won't work. Persist doesn't work without a transaction being opened. But the design of the API does not make it obvious that this is the case. So while you can call persist at any time in any context, you'll get a runtime exception if you do. There's no documentation to say that that will be the case, and you can't really detect it until you test it. I presume you test things. But you'll get a runtime exception. So how do you go about calling persist? The first step, if you're using Spring, which I am, the easiest way to do it is to mark a method as transactional. This tells Spring that the method needs to do things that require a transaction. Spring does something. I have no idea what it is. I've tried to read a stack trace. It's impossible. And then magically, you can call persist inside your transactional method. Sometimes. You actually need to understand how Spring injects its transaction management code into your code in order to understand how to use it. So this is how you are meant to use a Spring transactional method. So you have a business logic class, you have a data service, there's a transactional method inside the data service, you call from your business logic into the transactional method. It's pretty simple. But if you were to call from your business logic into a method that's not marked as transactional and then call your method that is transactional from the method that's not transactional, the transaction doesn't get created and you get an exception, even though you mark the thing as transactional. So that's really confusing. You mark the method as transactional, but you don't get a transaction. So why is that the case? Basically, under the hood, you need to know that when there is a method that gets marked as transactional, like this one is, Spring doesn't give you the object that you think you're going to get. Spring will give you what's called a proxy object instead of the original object that you think that you're asking for. It has the same interface, same methods, gets called in the same way, but it's not the same object. When you call into the dependency that gets injected, you actually call a method that sets up a transaction and then calls the underlying method in the underlying class. But it only injects that transaction management if you call into one of the methods that is called transactional from outside. So using the transactional annotation here, it's much, much easier than managing a transaction manually, but you need to know that specific implementation detail to make sure that you don't get runtime exceptions when you try to do something as simple as saving something to a database. So another problem with the JPA is that while find and persist are pretty easy to understand, not that whole transactional business notwithstanding, it's actually really hard to access more general queries using the JPA. So EntityManager gives you a method called createQuery. It takes a string that is written in a query language, like SQL, and it will return an object called a query object, and that represents the operations that you can perform on that query. Here is a selection of the interface of query. Just think about what you've got there for a moment. If you write a select query, you will get the same sort of query object as if you write an update query, which means that you can go create a query with the select and then go execute update. That will get you an exception. You actually need to call getResultsList, which is the thing that will run a select query as a select query. And if you do write an update method, you also have to make sure that you call execute update from within a transactional context. And then finally, if you call the correct method for your query, you write a select query you call getResultList, you still get a list of untyped objects rather than a list of things with a specific type. Newer versions of the JPA have some support for generics, and you can go create typed query instead. That lets you specify the underlying type of the objects to get returned. The interface is very similar. Related things are typed. But the problem is you still have to write the right sort of query. You can assert that the query is going to run cars even though the SQL says this is definitely going to return buses. There's no way for the compiler to detect this. You'll get a runtime exception if you try to access one of the things. So in summary, the JPA doesn't give you an API that guides you towards using it in the right way. And it relies on you to get type safety decisions correct. This is very much not how Kotlin likes you to think about things. So this gives us a good opportunity for us to think about what makes a good Kotlin API. So I'm going to give you these criteria. Firstly, it's easy to perform valid operations. So things that you should be able to do in a given context, you can do them and you can do them easily. If an operation is flaky, the compiler should help you make it safe. And then if an operation is known to be invalid, it should be impossible to write code that will perform that. So the JPA violates all three of these criteria. Not only is it impossible to persist an object without a transaction, it's actually easier to think you should persist an object without a transaction than it is to persist an object with a transaction, which means it's much, much easier as an unexperienced developer to get runtime exceptions in a working database, and that's not very good. For a bonus criterion, Kotlin likes type-safe code, so using an API in the way that the API presents to you should be completely type-safe by default. So, after getting frustrated with the JPA within Kotlin, I decided to work on making it easier to use and make it feel more like natural Kotlin code. So, the point where I started with this was methods that insert, update, or delete database entities need to be accessible from within a transaction and from nowhere else. The approach here is to make sure that to even see the API for a mutating method, you need to have opened up a transaction. So to simplify this, let's look at the simplest two JPA methods, find and persist. So at the core of the work that I've been doing, we have a data manager which wraps our entity manager. So the data manager is what exposes the find method on the underlying entity manager. And we also have a transaction method which constructs a transaction context object and will accept a receiver lambda that operates on that context object. Our run-in transaction method takes a transaction context, takes a block, and somehow runs it in that way. That's a detail that we'll leave alone for a bit, but basically just understand that when you call run-in transaction, which is what's called by this transaction thing, by the time the block gets executed, you'll be in a transaction. Okay, except that that's going to be a thing. So our transaction context object is what exposes the persist method. And importantly, we're using an internal constructor. That means the only way you can ever create a transaction context object is by using the transaction method. So you'll note that the JPA version of persist returns void. Our version returns the persisted object. That makes it slightly easier to use in cases that will become apparent shortly. The final thing is that I make use of Kotlin's reified generics and extension methods, and this saves us from having to explicitly use Java-style object introspection, which JPA relies on quite heavily. So with that, pulling an object from the database in Java with old busted JPA, you'll go EntityManager.find, the class object, and then the primary key. With us, you'll go DataManager, find class and key, or you can use the reified generic version, which is this DataManager.find with the explicit typing on your variable, which I think is pretty neat. And then instead of having to delegate to a separate object, you can now define transaction boundaries using Kotlin blocks. If you're inside a transaction block, you know that there's a transaction ready to go. And the other great thing is that because our version of persist returns the persisted object, our transaction blocks can be used to pass these entities across transaction boundaries whenever necessary. You can use the convention of the last line being the return value to persist an object. So you can go create a transaction that creates something and then returns it, and then that return value, the object that you persisted, is what gets returned to the calling context, which I think is pretty nice. So there is one problem, however, which is that if you want to update an object in Hibernate using find and persist, you need to retrieve the object from the database in the same transaction context as when you persist it. So this means that you need to call find inside a transaction block. But that means that find is under a namespace that is outside the calling context, and persist is in a namespace that is inside the calling context. That's not very nice. You'd prefer like the complementary operations to be at the same level of namespacing. So the solution that I came up with is to extract all of the fetcher methods into their own interface called hasFetcher methods. At this point, DataManager can implement that interface. And then we can pass our DataManager into our transaction context and use that DataManager as a delegate implementation. At that point, our transaction context automatically implements all of the public fetcher methods as well as all the mutation methods. And that means you can go with find and update that looks slightly clumsy to looking really nice and clean and easy to use. Kotlin makes it really easy to organize our interfaces much more conveniently like that. And that delegate implementation thing is like 3 extra characters. It's pretty great. So the question that I left open, which is, how do we actually get a transaction? It's actually pretty simple. We just create a component with a Spring transactional method in it. So this thing that I don't particularly like, we're still using one of them, but there is only one of them. The only thing our transactional method does is run whatever block of code we pass to it. So now we just have a single transactional method back in DataManager. We can call across our class boundaries into that transactional method, which opens and manages the transaction for us. If you don't want to use Spring, you can write your own transaction management code if you wanted to. But for us, we know that Spring has done hard work knowing how to implement transactions. Transactions are kind of difficult to wrap your head around. So we use Spring's thing, but we only have one transactional method, which reduces complexity quite a lot. So in summary, the big realization for us was to separate our retrieval and mutation methods into separate interfaces and then strictly control the availability of that mutation interface. And then finally, our delegate interfaces helped us make that API inside transaction blocks a lot easier to understand. So finally, let's talk about making our query API more Kotlin-friendly. As a reminder, we have find and persist. We've already sorted those things out. They're okay. They work fine. They're type safe. And now we have an API that makes transaction boundaries clear, so we can't use it incorrectly for the most part. But if we wanted to expose the rest of EntityManager through this method, we'd still end up with these non-type safe complex queries. You, the developer, have to do work to make sure your queries are type safe, and then all of your consumers get to make use of your type safety. So you, who are writing the persistence layer, have to do all the work in terms of making something type safe. The solution for us it's actually a Java library. It's called Query DSL. It's a type-safe query API for the JPA. To use it in a Kotlin project, if you're using Gradle, importing it into your project is simple as adding the JPA, the Query DSL support library, as well as their annotation processing library, and then rebuilding your project. So say we have a select query that operates on a table called items. The items table will have a matching JPA entity class. When you build your project, Query DSL will perform some code generation under the hood. It will produce a matching Query DSL helper class that maps out all of the fields on your entity. This helper class implements a thing called entity path. You can see that there. And the type parameter of that interface helps the type checker figure out the return type of your queries. Query DSL provides you with a couple of methods. Select from produces a typed JPA query based on the parameter type of our entity path. And then fetched on a typed JPA query returns a list of that type. And so if you put all that together, our SQL query from before looks a bit like this in Query DSL. JPA query factory, select from is the same as select, where is the same as where, and then fetch is the thing that goes and executes that query. You can use a static import so you don't have to qualify the helper object's name. This gets rid of that queue item stuff. Now, because you've called select from item, the type checker knows that the query that you're constructing here is going to return an item. So it's much, much harder to break type safety in this case until you start dealing with joins, but at that point, joins are hard. So update methods, they also look similar. You call update instead of select from, and you use a set clause to change fields. So Query DSL gives you this type-safe query language that's easier to reason with than writing raw queries. But the problem is that these still aren't mutation safe. Query DSL's query factory has the same issues as the JPA itself, which is that update and delete queries are still exposed when it's not safe to call them. So what's the solution here? The solution here is to do the same thing that we did earlier. Rather than using the JPA query factory that Query DSL provides directly, we expose our select from method from our data manager, and our mutation methods get exposed on our transaction context class. So suddenly, you can't use update methods outside of transactions, and it's great. So the final thing we did was to use some Kotlin features to make our query methods look a bit more natural. Because as Query DSL queries get more complex, you start seeing lots of dots and parentheses, and SQL doesn't have lots of dots and parentheses, or at least not nearly as many as that. And SQL is actually pretty natural to read. This, once you start getting complicated, isn't as hard to read. It doesn't look much like a query. But Kotlin has support for infix operator functions. And better yet, you can write infix operator functions as extension methods. So our code can now look like this. The process for creating these operators, like our EQ for checking that something is equal, it's a bit tedious. You have to do them one at a time. But from a code readability point of view, it's been paying off for us. So in summary, Query DSL, even though it's a Java library, makes our database code look a lot more type safe. But we needed to do work still to separate those selection, our reading methods, and our mutation methods. And then finally, our use of infix operators in Kotlin helped make our query language much more natural. So that's a quick overview behind the reasoning of the changes we made. Let's talk about a bit how far we got. So firstly, our work is incomplete. In our project, exposing APIs in our data management sort of happens as we need to write those methods. Similarly, we don't add infix operators until we need them, so we haven't implemented all of the Query DSL operators that we need to do whatever query we would like. But as we use them, they appear, and most of the queries, well, every query we've written has infix operators at this point. So our work is piecemeal, but at this point, the effort to add these features is so low that we can just do it incrementally as we need to. At the moment, I don't have any code online to show you. Our implementation is very project specific. This talk sort of shows what it would look like if I released it as open source. I might do it at some point. And that would make it generic and reusable by other projects, not just within Alpha sites, but hopefully for you as well. And finally, our transaction support requires you to be using Spring and Spring Boot. And really, this shouldn't be to your liking. So finally, going to make it generic and reusable, potentially open source it so you can take our ideas, build upon them, improve your JPA code without fighting the same battles as we did. A reminder, Alpha Sites is hiring. If doing interesting back-end engineering work in Kotlin in a really fascinating field is something interesting to you, you should have a chat with myself, Matt, Nico. There's a bunch of us here. Come and have a chat. Thank you very much.